the second in a series of seminars aimed at presenting highly relevant topics for dentists. My name is Farah Hossain. I will be your moderator in today's session. We've got a lot of interesting content for you, and I want to get to that. But the first thing I'd like to do is give you a little bit of information about how we will run the session and how you can ask questions. So the format is going to be as follows. There will be a brief presentation by all of our speakers to establish context for the discussion. And we'll then move into addressing specific topics of interest that you've raised or that we have been hearing over the past several weeks. I invite you to submit your questions live by using the Q&A button on your screen. I will do my very best to get to your questions, but we have a very, very large number of attendees today, and I don't think we're going to be able to get to all of them. If we run out of time, we will endeavor to answer your questions by email after the session. Note that when you're asking questions, you do have an option to ask anonymously or to ask by identifying yourself. If you ask anonymously, we will not be able to respond to you, so keep that in mind. Now we can get into the main discussion, and that discussion, we've got a really long title, which you can see there on the screen, but essentially what's happening is in many parts of the country, HVAC considerations will determine how quickly and effectively you can restart your practice. Dentists in quite a few provinces are required to allow their operatories to sit idle, either to allow aerosolized particles to be removed or to settle. Even in provinces where there are no mandated fallow times for operatories, questions abound about how to reduce the risks to yourselves, your staff, and your patients. Our goal today is to give you some information to help ease your transition back to full practice, and that's why our series is entitled Getting Your Practice Back to Full Value. At this point, I'm very excited to introduce you to our distinguished panel of speakers. I know you will be impressed with their resumes, and collectively, they have about a century of experience. I need to let you know, though, that they are not positioned to provide definitive advice to you regarding validation of requirements set out by provincial college boards or anything like that. But they are experts in their field, and they are aiming to provide you with information to assist in your decision making. So keep that in mind as we go through. Now it's time for me to introduce our speakers. And when I introduce the speakers, I'd just like you to wave your hand so people can see who you are. The first speaker I'd like to introduce is Dr. Jeffrey Siegel. Jeff, there you go. Jeffrey is Professor of Civil Engineering at the University of Toronto, and he's a member of the university's Building Engineering Research Group. He holds joint appointments at the Dalla Lana School of Public Health and the Department of Physical and Environmental Sciences. He holds an MS and a PhD in mechanical engineering from the University of California, Berkeley. His research interests include healthy and sustainable buildings, ventilation and indoor air quality in residential and commercial buildings, control of indoor particulate matter, the indoor microbiome, and moisture interactions with indoor chemistry and biology. And let me tell you, folks, that's not even the whole resume. I cut it short by a lot. So we welcome Dr. Siegel with us. Our next two speakers are from Pynchon Limited. Pynchon is one of Canada's largest environmental engineering, science, and health and safety consulting firms. Graham Terrace is National Practice Leader. Hi, Graham. For the mechanical division of Pynchon. He has over 40 years of experience in heating, ventilation, and air conditioning in Europe, Canada, and internationally. He is a professional engineer in British Columbia and Saskatchewan, and a chartered engineer in the UK. He sits on the Public Construction Council of BC and the Building Engineering Committee of the Association of Consulting Engineering Companies. Next, we've got David Gardner. David is a senior occupational hygiene and safety consultant and National Occupational Health and Safety Practice Leader with Pynchon, with more than 30 years of experience as an occupational hygienist and general health, safety, and environmental practitioner. He has extensive experience in hazardous materials management, occupational hygiene, and respiratory protection. So David, did you wave? I missed if you waved. Okay, good. And last but not at all least, we've got Dr. Bernie Dolansky, who is with Tier 3 Brokerage. Bernie, can you wave for the 2% of people that don't already know you? Okay. Bernie has had a distinguished career, distinguished dental career. He practiced and taught endodontics for 37 years, during which he transitioned in 3 partners and numerous associates. He has served as president of the Ottawa Dental Society, the Ontario Dental Association, and the Canadian Dental Association. And he is a senior transition partner with Tier 3 Brokerage. Bernie, I'm going to invite you now to kick off the discussion. Over to you. And you're on mute, so if you can please unmute yourself.
Thank you, Farah. We're here today, as Farah said, to talk about the best way of getting your practice values back to where everybody would like them. We're in a period of uncertainty, although we are getting more and more direction from our regulators across the country, and indeed, if you're following it, across the world. What is distinguishing, if you are following this at all, from the regulators? Farah, could you put up my slides? If you're following this at all, there is great consistency in some areas of what we're hearing from regulators and a lot of inconsistency in other areas. And our
Bernie, I forgot to talk to this, so you can talk to it, but this is what we thought many people listening in today and looking will be thinking.
Well, it's what I'm talking about right now. It's
yes.
A perfect slide. Confusion reigns, especially in the area of aerosols, today's topic. If you're a practicing dentist, you know all about aerosols in one sense because many, if not most of our procedures produce them. But I'll bet if you're like me, you've never given them a lot of thought until the last few weeks. They're just there, we handle them. The most common way, of course, is with high-speed evacuation. And we've never actually looked at them as a source of danger and a source of uncertainty. And that's reflected in the regulations around the world in that last slide that we saw briefly. Everybody's scratching their heads. And the reason for that is we don't know. And that's the bottom line. We know we produce them. We don't know a heck of a lot about what's in them and how dangerous what's in them is. And that's why we're here today. Periods, just generally to talk very briefly about practice values, because that's the context in which we're trying to find out more about how to handle aerosols. Periods of uncertainty like this are not good generally for asset values. Certainly that's true of dental practice. As I say, we're getting a little more certainty and direction, but we believe that, and we've seen that practice values have dropped in the short term, and we believe that's going to continue into the midterm. The long term, we see a lot of reasons to be optimistic. Values are going to get back to where they were. The big question, of course, is when. We see reduced prices at least through 2020, sometime in the next 12 to 18 months. Based on the history of dentistry, we've been extremely resilient through past crises, and we think, given everything we see and know, prices will get back sometime in that period. Very briefly, what determines practice value? Many, many factors go into it, but largely it's the revenue of the practice, more importantly, the earnings or profits that are derived from that revenue, and then what's called the multiple. how many times those earnings somebody, a buyer, is willing to pay. And those multiples are basically a measure of the risk involved in the investment and the demand for that particular investment, in this case, dental practices. We're not exploring that today, but that's just background. We don't know the magnitude of the decrease in values in the short term. The market's going to tell us that, but we do know it's driven by those regulations and the pricing decisions that are coming from them. Aerosols are playing a huge role in the restrictions we see on the procedures we can do, the requirements for PPE, and a couple of our people today are going to talk about PPE, especially masks and N95s, and the fallow times, the disinfection times, the time it takes to don and doff PPE. What's that doing to patient schedule? And what's that doing in turn to production and revenue? Very briefly, there's a lot of talk about fee guide increases and how we're going to cover those. That's another topic. But there is agreement out there that the aerosols are important, but as I said, very little agreement on anything else. The standard that a lot of people are referring to, and if you're listening to this in Ontario, you may have heard the rumors that there may be changes in the RCDSO directions, and those changes will go more towards the CDC recommendations. If you've read the CDC recommendations, you know that today's topic, aerosols and air quality, are a major part of those requirements and recommendations as well. So change or no change, this is relevant. Next slide, please. So what are we trying to accomplish today? We're trying to get you and your practice to the point where you know what needs to be done so that you, your families, and your personnel and patients are safe. We're trying to interpret the licensing authority's requirements in a way that you can meet them, but dental practices are businesses. They're unique businesses because they do deliver healthcare, but they're still businesses. So all this has to be done in an efficient manner, a cost-effective manner, and maintainable manner, and in a way that will allow us to run our practices in a way that, as one of my clients said to me and other people have said, show me the money. At the end of the day, my practice has to make some money or I can't afford to keep my doors open. And now I believe Jeff is going to speak next.
Yes. Yes.
Okay.
So Jeff, over to you.
I need to be able
Stop
to
share.
share. Yeah, there we go. All right. Good afternoon, everyone. What I want to do today is kind of address two things predominantly. The first thing is, although I have no expertise at all in dentistry, I'm not a microbiologist, I'm not an infectious disease specialist. What I do have expertise in is particle and aerosol dynamics and removal approaches like filtration and ventilation. So what I want to do is give you a perspective on those, as well as talk a little bit about an evidence basis for making decisions about reducing the risk of disease transmission. So that's kind of the starting point here. And I want to acknowledge that, you know, we're dealing with a very fundamental problem. When I was speaking with my department and with my colleagues about reopening the department and restarting labs, I started that presentation by saying, well, just be glad we're not all dentists. And obviously, we're in a situation where there is some possibility of disease transmission risk because of what you do. And, you know, I think we can't really quantify that risk right now, but I think it's almost certainly that there is very large variation, and there's a bunch of factors there, for instance, what procedure you're doing. But what I'm going to talk about today is how the building and the specific details of your physical practice influence some of the transmission risk. And the quote there I put from Dr. Pettenkofer, who's kind of the acknowledged great-grandfather of indoor air quality science, I think is very relevant here. Our first goal is source control. And so what we ultimately really would like to do is not have the source in the first place so that we don't have to deal with the somewhat messier jobs of filtration and ventilation. But we obviously can't control the source in this case, so hence this presentation. To start at the very beginning, this is a basic schematic of an HVAC system. There are small variants in different buildings, but they all fundamentally look something like this. And I don't want to go through the details here other than I want to identify a couple of points. One is that typically air comes from the building. Some of it is exhausted, some of it is recirculated. And then fresh air comes in for the purposes of ventilation. There's a filter, hopefully, somewhere in that system, and then the conditioning equipment, and then the air is supplied to the building. So that's kind of the very basics of how this operates. The other thing is there's a lot of complications here. There's whole fields of people who study HVAC systems and some of these complications, and I'm not going to go through them. I just want to highlight one of them, and that is the HVAC system is not the only thing going on in your building. There is very often other airflows. So for example, if you have an open operatory, you're going to have airflow between the operatory and the other spaces in the building. And those airflows can, in some cases, be much larger than anything going through the HVAC system. So it's not the only variable we have to talk about. But to the extent that the HVAC system is important, the other thing we have to acknowledge is that there is a great diversity of HVAC systems in our buildings. And you might agree more with, or in your building, it might be more like the situation on the left. In other buildings, it might be more like the situation on the right. You know, of course, it's a continuum in between. But the bottom line is that in many buildings, the HVAC system might not be up to the task of trying to reduce infection risk. And so part of the reason why it's very hard for someone like me to give general, broadly applicable, you know, very prescriptive guidelines is because there is this diversity. Okay, so the job fundamentally of the HVAC system in the building is to, in this particular context, is to we want to remove any aerosols that contain the SARS-CoV-2 virus before we have disease transmission happen. And there's a whole lot of unknowns here. There's very active research going on, but you know, just to go through some of them very briefly, we don't even know the size distribution that's relevant for containing the virus. And there's a lot of different sources and a lot of diversity in possible droplet size distributions. Even if we do know that for a particular environment, there's a second question about just because the RNA of the virus is there, does it have the ability to infect? And there's real questions about viral loading and those sorts of issues. And even if we had complete knowledge there as well, droplet size is not a fixed parameter. Droplets change in size very rapidly from the point of emission. And one of the big reasons is, for example, interactions with humidity. So in dry environments, the droplets grow. In moist environments, in dry environments, the droplets shrink. In moist environments, the droplets grow. So when we think about what the building does, or what people like me think about in the building, there are three main processes. I'm going to talk briefly about each one. And I'm going to start with deposition. This is the process by which things are removed from the air because they are transferred to building surfaces. And deposition has been studied for decades and decades in indoor environments. And you can see by the table in the lower left that deposition rate is a strong function of particle size. So for some of the particles we're probably talking about, deposition rate is essentially negligible. For other particles that we're talking about, you can see very, very high deposition rates. In many dental practices, probably higher than the ventilation air exchange rate. So deposition is this important removal process, but there's a lot of complications here too. Just because it's depositing on a surface, it's not being removed from the environment. It's being removed from the air. So we still have to address cleaning, and deposition happens to a variety of surfaces, not just horizontal surfaces in the floor. The other thing is that we track around particles as we go about our activities in different spaces. So if a particle does deposit on the floor that contains the virus, that can easily be carried to other environments by, for example, someone walking or wheeling a cart or a number of other means. And then the last point here is that we also have resuspension. Again, there's been decades and decades of research on this phenomena. Just because something lands on a surface, it doesn't mean it stays there. It can get blown into the air, particularly by, for example, high air velocities. So that's another issue to pay attention to. There's been some discussion, obviously, of filtration as a means of removing particles. And I show this maybe somewhat complicated plot for one very simple reason, that filters don't have a constant efficiency for all particles. They have what's typically shown as this U-shaped curve here, and every filter is going to have a different U-shaped curve, and that means they're generally speaking more efficient for very small particles and for very large particles, and there's kind of a dip in between. And so there has to be a little bit more nuance than just a single efficiency value when talking about a filter. The way we usually address that is with some type of reporting or rating system. One example of that is an ASHRAE standard, and that's where MERV, which you probably heard about, comes from. And the only point I want to make on this slide is that you know, the MERV, as the MERV goes up, generally speaking, the filter efficiency increases. And if you're talking about very low MERVs, at least for the particle sizes we considered here, you're talking about relatively low levels of removal. And so you have to get up into the higher MERV levels. And HEPA is not a filter that you would test with ASHRAE standard 52.2, but a HEPA filter would have a curve that is almost completely flat at 100% with a small dip. And I'll talk about them more in questions if there's interest. Now, the problem with even if having a MERV is that a MERV is a fixed quantity. The actual performance that the filter gets is a function of the building and how that filter is, as well as the filter itself. And just as one demonstration of this, this is the exact same MERV 14, so a relatively high performing filter installed in 20 different homes in Toronto. And you can see that its measured installed efficiency ranges from close to 0 for a lot of particle sizes to above 70%. And so the filter isn't the only thing that matters. How it's used matters too. And that really complicates being able to make a specific MERV recommendation. The last approach that is kind of in the toolbox is ventilation. And ventilation, as I use it, means dilution with outdoor air, not the flow through the HVAC system. And remember that HVAC systems have recirculated air. So some amount of the air, typically a number like 80% or so is not uncommon in an air-conditioned building, is recirculated back through the building for comfort and energy efficiency purposes. And so when we think about ventilation, we might be thinking specifically about some of the fallow time requirements. And, you know, I'm sure there'll be lots of discussion of them, but let me just give a little bit of my perspective as an outside building scientist on those requirements. You know, I absolutely agree that more ventilation, truly ventilation with outdoor air, is going to reduce fallow time. However, I'm going to raise some concerns. First of all, I think the threshold of 99.9% reduction in particle concentration is quite conservative, especially given what we know about kind of dose-response relationships for the virus. The most important point is the point I made on the previous slide. Flow through the HVAC system is not ventilation because of that recirculation component. I made the point earlier, internal flows in the buildings that are separate from the HVAC system can be very important. So you might just be, by waiting a period of time, distributing the virus to other parts of the building. And the other issue, and I'm not going to do anything more than stated at this point, is that increasing ventilation is actually kind of a complicated thing to do in many buildings. There are real issues about equipment capacity and other potential downsides that occur when you increase ventilation. And so there's a lot of other approaches that I think are probably, again, from an outside perspective, worth considering if your goal is to reduce fallow time. Some other approaches that I think are worth discussing, and I'm just going to mention them here, and I have slides on each of these if the people want to talk about them during the Q&A. But you can capture emissions at the source, as I know many of you do in your practice. There are high flow extractors that kind of try and capture the emissions closer to the patient rather than in the room itself. There's already been some discussion in the Q&A about portable HEPA filters. I think we'll probably want to have some discussion around ultraviolet lamps, and there are real kind of issues with using them. Simple solutions like trying to limit the transfer from the operatory by things like track-off mats. There is kind of a downside here in other approaches too, and here's another quote from Dr. Pettenkofer, and I think that's relevant. There is a variety of approaches that are being marketed generally as well as specifically to dentists. Some of them are listed here. And I'm just going to suggest that you should be cautious and a good consumer before going down too many of those pathways. There are issues around ozone emission. Ozone is a respiratory irritant and will engage in a lot of chemical reactions within the face that can lead to harmful or damaging byproducts. There are real issues around effectiveness of some of these products in their actual use, as well as products don't necessarily perform consistently over their lifetime. Just to wrap up here, a few additional points. One is that, there's a lot of discussion, and I anticipate a lot of discussion on the operatory, and I think that's appropriate, but don't forget you have other spaces in your practice too. Some ones that I think are worth considering from an aerosol science perspective are certainly the bathrooms, waiting areas, as well as this problem of transport between spaces in your practice. And another point that, I like to be as optimistic as I can, and I think that, the best solutions here are going to be things that are long-term and sustainable for the practice, and that they'll overall improve the health of the patient, of your patients and your staff. And I think that we want to be cautious a little bit in rushing to some solutions, because the research is really emerging very rapidly, and anything we say today might change on a very short time scale. And so to finally wrap up here, COVID-19 is a controllable risk. I think you're looking at some very conservative guidelines to try and meet. I think you should consider a full range of filtration and ventilation options to achieve your goals. And I think this is really, as much as it's a bunch of challenges, it's also an opportunity to really invest in an aspect of your practice that you probably haven't given much thought. Thank you.
Thank you, Jeff. We appreciate that background context. And with that in mind, I'm going to ask Graham to continue with the presentation at this point in time, to give us a little bit more about what Pinchin does and how they can help us with what needs to be done. So Graham, I'm going to just get to your slide here, and it's all yours.
Okay, as you'll hear, I'm from Scotland. I'm not going to use subtitles today, so I'm going to do my presentation in English. So what I want to do is go a lot of what Jeff says is some of the stuff I'm going to go through, but I don't think it's some of it will bear repeating for sure. Oops, where did that come from? Yeah, okay. So what I want to do is, the previous slide was one that Jeff went through, which was a typical HVAC system. The virus has a long distance to go through before it gets back to that filter. It's going to be, if it's trapped in the air, hello? If it's trapped in the air, you're going to get a lot of, it's going to hit a few corners on the way back. It's going to hit fans, it's going to hit louvers, even before it gets back to the filter. So your ventilation system is, in a commercial property, is a very important factor. So what the concern is really more about the air flows. And there was a famous project that was looked at in China, which is the Guangzhou Cafe. The problem here was there's an air conditioning unit on the right-hand side of the cafe. Now, an air conditioning unit isn't the same as an HVAC system. The HVAC system that Jeff showed you is more what you're going to have in your surgery. If you have an air conditioning unit, it's more like a blower. It's blowing air, it's turbulent. The air turbulence is what's helping cooling the space. Now, patient A1, you'll see the guy on table A, he was an asymptomatic carrier of COVID-19. And the airflow across the tables made the 2-meter distance irrelevant in that case, because the airflow and the draft was pulling the aerosol transmission further than the 2 meters it would normally be. So that's important to think about going forward. So what your system, as Jeff was saying, you've got 2 different types of systems, but I tend to think that ones I've designed are properly designed. We tend to try and avoid drafts wherever possible. And sometimes these systems can go out of balance because you've changed your internal layout, you've altered your room size or something like that. And because of that, air balance moves differently from what it was designed to do, and your grills then start to create more drafts than they previously did. So how do you reduce drafts? And drafts are the big thing. If what Jeff was saying about the reduced humidity and reducing your droplet size makes them more buoyant, so the drafts become really important. And if you've got less occupancy in your space, maybe that's not quite as relevant in a dentist surgery, but in an office certainly, you've got less occupancy, you've got less cooling load. If you've got less cooling load, you can turn your air volumes down a little bit, you can put more fresh air in, you can bring less research back. You can look at free cooling. You can, in certain climates, you can look at nighttime flushing. Now, what the general advice is you could, if you run your system for a couple of hours after your practice closes and run it for a couple of hours before it opens, then you're taking the possible impact of cleaning out of it, and what we talk about when cleaning can introduce resuspension back into your area. So you can operate your system on full recirc for that time, and that will certainly help reduce the the suspension there. Humidity is important, if we can keep it to the 40 to 60%, but most of you won't be able to control the humidity in your space to that degree. But generally in summer, it's not an issue. It's more winter time that we tend to worry about the low humidity. Washrooms are an issue, as Jeff mentioned. What a lot of people have done is they've closed off the 1 in every 2 cubicles just to keep the social distancing. When you flush a toilet, there is aerosol pushed into the air. Generally, toilets work on a decent air change rate, and their extract grows over the toilet areas, so your drafts aren't quite so much of a problem. But what you really need to do is make sure you operate that system 24/7. If it operates with a light switch, try and recalibrate it so it operates full time rather than on the light switch or on personnel detection or anything like that. This is not my family, honest. Practical issues of changing filters. I'll just go through this quickly. Very hard to put HEPA filters into an air handling unit, so don't even think about it. It's not going to work. MERV 13, 14, you can certainly change filters in the existing frame size probably, but just make sure they're properly gasketed and properly sitting in the frames, otherwise they become more or less useless. Fan pressure drop isn't really a problem because you're changing your fans, your filters more regularly, so it's not so much of an issue. And health and safety is important. When you change the filters, you should be using PPE and bag your filters when you change them. This is the RCDSO document, which you'll all be familiar with probably. It's as Jeff says, it's very conservative in terms of the turnover rates for your rooms. I'm trying to get back to that one. Anyway, the table basically talks about fallow times and air change rates. If your air change rate is greater than your fallow time is shorter, obviously you want to keep your fallow time as short as possible. So what's going on here? Right, so this is the table here. Generally, your air system will operate. Your normal HVAC system will operate around about 4 air changes an hour, which will give you a fallow time of around about 104 minutes, which is a long time. I think the document guides you to the fact that you might be able to utilize a portable air cleaner on top of that, which will increase your equivalent air change rate to getting on for the 20 to 30 air change range. If you add a portable air cleaner to your operatory, you'll get up to that sort of range, and the filtration will allow you that air change rate. However, the thing to think about when you're doing that is that you've got to make sure you're not creating more drafts when you do that. So positioning of the unit is quite important. I'm trying to get to a picture of one. this is part of the section 44 of that document, but basically it's suggesting you should use an HVAC professional to check your air change rate on your existing system before you add anything additional. It may well be your existing system will provide a better air change rate than perhaps you think. But the other thing to think about is if you increase your air volume too much in your system, then you might start creating drafts, which goes back to what I was talking about earlier about the drafts being an issue about carrying the virus. So this is what a portable air cleaner looks like. That was what a portable air cleaner looked like. It's basically around about 300 diameter, 800 millimeters high. They do about 400 CFM, and they have a HEPA filter built into them. They probably sit relatively easily within your space. As I say, around about 30 air changes you would expect from something that in an operatory that's maybe 10 foot by 10 foot by 8 foot high. Obviously, the bigger the operatory, the less the air change rate. So, but you have to make sure that your operatory is closed off to get that advantage. Other things to watch out for, back to this draft thing again, desk fans and wall-mounted AC units. These are two enemies of the transmission, really, and I think we want to avoid that wherever possible. The other thing to do is decouple any demand control ventilation, provide as much fresh air as conditions allow, upgrade your filters, change filters often, where drafts exist, try and get rid of them. That's really the messages. On to David.
Okay. I don't know how far along my slides are, but I'll try and get to them.
Should be okay now, David.
It's not advancing.
Do you have it now?
Yep, that's my name. So anyways, what I'm going to talk about, and hopefully we can get the next slide to come up, is really the other parts of it. And I think one of the critical things about this whole process, when you're thinking about it from a holistic point of view, it's not just the ventilation system that's going to save you and your staff and your patients and really the whole world. We really need to be able to think about all the things that we do as being critical to the success of beating this COVID virus. Because if somebody decides to go out when they have disease, then that's going to circumvent our ability to generally protect ourselves. So it's not just me keeping 2 meters apart from somebody, it's everybody doing that. It's not just me staying home, it's everybody trying to do that. And in your practice, it's providing that ventilation that's going to try and reduce the aerosols in the air, but also washing your hands and your staff and your patients washing their hands and good hygiene and all the other things that go with it. So, sorry, I just can't get the slide to index past. I don't know if you can try doing that, Farah.
Sure.
Okay. So those are the things I was just talking about. And one of the things I wanted to highlight on top of this, I know we're talking about HVACs, but mention obviously we provide a broad range of services, including respirator fit testing and those kind of things. And just a couple of things just to talk about. I mean, obviously good hand and face hygiene is something that's going to be very important. And I think, looking at the guidelines coming out from the Royal College for Dental Surgeons of Ontario is that there's a lot of very specific guidelines in there that all have to fit together. And if we don't do them all, then there's going to be a chance of risk. And what I always like to talk about as a health and safety professional is risk assessment. And this is the first stage is really, it's very difficult when you have a bunch of prescriptive measures that say you have to meet this number of air changes, you have to do this, you have to do this. the more logical approach is to look at the actual risks that are there and control them, because that's going to be your most cost-effective and efficient way of doing it. So again, just following all these recommendations blindly is not going to necessarily achieve what you're looking for. So one of the things is masks. So we need to use masks and respirators, and using other PPE. And the most important part of the risk assessment thing is the fact that you're trying to reduce your exposure time and the concentration. Because that's the other thing that a lot of people are missing. Social distancing and keeping 2 meters apart from somebody is based on casual, short-term exposures to other people. And a lot of people don't think they think social distancing and all they think about is, oh, I just need to keep 2 meters away from somebody. And that's not the case, because the data seems to be showing quite clearly that it's the amount of time and the amount of viruses in the air that creates the risk. And if we can limit your time exposure, then the concentrations can become less important. And again, reducing concentrations is the other approach. And the other is making sure you're organizing all this into a management plan. Now, I'm not suggesting, I don't think people have a lot of appetite for developing these wonderful plans, and we've reviewed a number of them for some of our large clients. But you need to be thinking about logically what you're going to do and how you're going to do it. And of course, the document that comes up from the Royal College actually provides a lot of very good instruction in there that you should be worrying about. But one of the things is respirators, and I'm sorry, I'm trying to remember what I have on my next slide there.
I'll take you there.
Okay. Okay. So just to talk a little bit about respirator, because this is what you're going to use fundamentally to protect yourself and to protect your patients. So N95 respirators provide protection for the users, and this is a very unique thing. So I cannot see myself coming up here. I need to be able to see myself. So this is a P100, so the highest level of protection with a half-face respirator, and this will absolutely provide the best protection compared to an N95 respirator. And these are, I mean, everyone talking about N95s, I don't really know if they know what that means. What it means is you're getting 95% filtration efficiency at a certain size of 0.3 microns, but this one gives you 99.9. The problem with this one is, if you see right on the front here, there's an exhalation valve. And that is unfiltered. So even though I'm getting the best protection I can for myself, the people around you are not getting the best protection. And you can imagine, as you're providing your services, that you're leaning over top of your patients. And if you have that exhalation valve on there, or if you have an N95 that has this little button on the front of it that's not actually designed for medical applications, if you've ever worn a respirator, and I would imagine you've worn surgical masks before, you know how hot they can be. You can get moisture building up in them, and something that's plastic like this one, you can actually have stuff dripping out of that exhalation valve and around the respirator itself. So these are things obviously we want to prevent from getting into our patients' eyes and mouth. So you need to be very careful in picking these things. And this is why the N95 is the respirator of choice, because it doesn't have an exhalation valve. So it protects you and it protects the people that are around you as well. These things, they do, the requirement is that they are NIAS certified or ASTM certified. There's some medical designations out there. And what is happening is, as you know, there's been a lack of getting N95s. And I know there's a lot of dentist offices that we've been dealing with to do things like fit testing, and we haven't been able to do them because you cannot get your hands on an N95 respirator to even do it. I don't even have one to even demonstrate, so I had to use a picture here. But typically they're NIAS approved. You can go to the big box stores and you can buy what they may call painter's masks. And typically two of the ways you can tell that they're not NIAS approved: one, they may only have one strap on them, and the others, they're not going to have that NIAS approval right on it. If you see kind of in the bottom, all that wording, you'll see the word NIAS there, and they'll actually have the NIAS approval on it. The thing that's happened, because these are becoming more difficult to get a hold of, Health Canada have started recognizing KN95s, which come from China, other ones that come from Europe and other places that NIOSH believes typically they meet the NIOSH standard. The problem that has been with them is, one, they're very hard to get fit tested, particularly if you have KNs that have the ear loops on them. And our recommendation there is if you get your hands on those, because when we come and do fit testing, it's very difficult to get a successful fit test. They have these things called ear savers, and it's just a little plastic piece where it essentially pulls the respirator a little tighter on your face and you get a better seal. And the other issue is that the manufacturing, our experience has been, is some of the manufacturing of the stuff doesn't quite meet, even though the original design meets the current standard, it doesn't mean that that respirator is going to be a good fit. And I think what you want to achieve is having confidence that you actually have a good fit. And this is why we do fit testing, and why it's very important to not just do the fit testing, but teaching people how to put their respirators on properly. Like, for instance, this one, just to give you a simple example, you put that respirator on your face, you put it in your hand, you can see my hand here, you cup it, you put it up on your face, you put it on, you put the straps one below, one over the crown, and then you take two hands and you squeeze that little metal piece so you get a good seal around your nose. It's not with one hand, it's with two hands. So there's a lot of little secrets that hygienists know about getting good fits with respirators. So anyways, you just need to be cognizant of that we're using other ones that may not have the same level of quality that the NIOSH certified ones will, but they certainly are acceptable. And we certainly recommend, if you're wearing a respirator, that you get fit tested. One of the things happens with these is these things have an expiry date on them. And we had a client who had about 100,000 N95s. They obviously, when SARS came around, went out and did some business continuity planning, and they had these things out in a sea container, but they sat there for over 10 years, and the respirators essentially expired after 5. So the question was, can we use them? And you were saying, well, how do these things expire? It's just filtering material, and true enough, I would agree that the filtering material probably doesn't break down too much over that period of time, but where you get problems is the elasticity of those straps to actually hold that respirator tight to your face. The materials that are getting the nice form around your nose can deteriorate. The metal parts can, rust and get other deterioration. So you need to be very careful if you're using things that have exceeded the expiry date. But again, Health Canada have been trying to provide as much latitude as possible for people to use things. And if you inspect these things properly and understand how they work, then you can wear respirators that are technically expired in these days where we just can't get the respirators that we're needing. These N95s are generally considered to be single use. That's what they're disposable. And what you have to understand is when you put these things on, and then when you take them off, they start getting deformed. And the more times you take them off and put them on, and take them off and put them on, I've come from an industrial workplace where people take them off, stick them in their pocket. You're not going to get that good seal the next time. So you really have to take care of them. And I actually we have a fact sheet out, and there's a very slick little video that we have in there. And it shows a person with a little container. I'm trying to think of doesn't matter, the little plastic container. What they do is they put the container up to their face, they pulled the straps over, and then they pulled it away, and then it actually maintained its continuity. But again, they were designed to be disposable, and so the questions come up, well, can I reuse them? Will they get contaminated with the COVID virus as I'm using them? Yes, they certainly will. So there's a lot of things you can do. There's ways you can take them off and on. Again, using this little plastic container that this video came up with means you're not touching them with your hands. So again, we go back to hand hygiene, how important it is to make sure that before you put your respirator on, you've washed your hands or used alcohol-based sanitizers. And before you take it off, like they do say, some of the guidelines are, well, after you take it off, wash your hands. I recommend you wash your hands before you take it off, because that's going to prevent you from contaminating the respirator with your hands. and try and keep it as clean as possible. Again, Health Canada is allowing, with some limitations, that you can actually clean these things and disinfect them and use them again, because there's just not enough of them around. When there eventually is enough around, you know, we're going to go back to the old rules where there really are, you shouldn't be, you know, if you're using them all day long, that's probably going to be a long time. You're probably only going to get, you know, 2 to 4 hours out of these things. But again, we're trying to stretch out the resources as much as we can. And then we get into face masks. So what face masks do, it took a very long time for the health professionals to come up and say, oh, we think wearing face masks would be a good thing to do. And certainly I would have told you that long before March. Like when this came out in when SARS came out, it was quite clear back then that, because I had these first questions about why aren't these people in healthcare, why aren't they wearing, you know, these nice little half-face respirators protecting themselves, and why do they think these surgical masks can protect them? And Health Canada way back then said, yes, they do provide protection. And I think it's fairly clear, if you just think about this logically, that if you're breathing through something, it's going to knock down the amount of aerosols that you're releasing. And so as Dr. Tam is saying, we believe that these face coverings are going to protect other people. There's no doubt in my mind that even a poorly fitted respirator provides protection from industrial hazards, that it is going to provide some protection from some of the aerosols in the air. I can't give you specific data on it, but you just think about it logically. Most of the air you're breathing is coming through the mask that's being filtered. You know, some of it certainly can leak through the sides, but you're getting some protection. So these are good things for your staff to be wearing, or of course putting up plexiglass shields and all the other things you need to do. But these are all things that are going to provide additional protection, because we're trying to reduce the time of exposure and the concentration. Now, the last thing on that slide, you don't need to go back to it, is just, why do you need to do fit testing? Well, there is a CSA standard that says it. And again, you and your staff want to feel confident that when you put a respirator on, it's actually providing the protection that you're looking for. And that's what fit testing will do for you. So to put it all together at the end here, we need to do risk assessments and determine where the exposures are and control the ones that we can control, because we have to try and reduce the risk as much as we can, and we have to be practical. And some health and safety people, I believe, from my experience, come up with these full 9-yard solutions that really go well beyond what's actually required. And so we always have to think about practicality and the things that we have to do. Develop a plan and how you're going to manage it and make sure those things get followed. If you're having arrows in your offices, people coming in through one door, you have plexiglass enclosures in front of your staff, and then they're doing things like stepping around them and not following all the rules. These are all the things you need to do to reduce the thing. So come up with a plan and really make it work. And the last thing that unfortunately we're into, because I think you've heard all 4 of us say, there's a lot of data we don't have. So there's this thing called the precautionary principle, where it says if we don't know, we put in controls to the nth degree. And unfortunately, that's kind of what's happening. Daily, I think information's coming out on COVID, where we're learning more and more about it, because it's obviously a big deal in the world, and a lot of researchers are digging into it. So I think we'll lean less and less on the precautionary principle and more on actual data to come up with our solutions. So thank you, and I guess we're looking for some questions, and I see that it looks like there's about 34 of them at least already. So thank you for your time.
Thank you, David. Thank you, Graham. We've got a lot of questions that came in, and I'd like to get right into the questions now to make sure we give people the benefit of the time. So the very first, I'm going to start with some basic questions that have come in. I believe these questions are on the minds of many of the people listening in. The question is, should we be concerned that our HVAC system will be spreading virus from operatories to other parts of the office?
Yes.
Yes, absolutely. You know, of course, it depends how much of a risk that is, depends on the details, but it is absolutely a risk.
Okay. So in that case, what to do if the building landlord does not have the information to give me about CFM of their own HVAC? Are they going to call somebody to do it? How do I get in control of that situation? Can I work around it, assuming a base standard for CFM?
I mean, the guidelines refer to a base standard of 2 air changes an hour, which is a relatively good base standard to work from. I think you need to work out whether you're under positive or negative pressure. You need to work out whether there's drafts, basically, back to what I was saying earlier.
Yeah, I would add to that, the reason there's been some questions about whether an HVAC professional should be involved. And I think that the real reason that you need an HVAC professional involved is that there is not a lot of standardization in HVAC systems. So just the simple idea of what is the actual flow, that's not something that anyone can see a diagram of the system and say, oh, this is the actual flow it's providing. And so that's why you need someone to be able to do that. Now, having said that, again, if there's recirculated air, I'm not sure what the point of that measurement is, because some of that air, depending on the building, is just going to spread, going to take the air from the operatory and move it to other spaces in the building.
Mm-hmm. Does ACH refer, Jeff, to fresh air to the building or air to the operatory? Just for clarification.
Great question. And I'm not talking about any official definition. I'm saying that the right definition is fresh air coming into the operatory. My reading of the document is that it is air coming into the operatory, or air flowing through the operatory in the HVAC system without regard to whether that's fresh air or not.
Okay. So in that
turnover, basically.
There are many, many questions around HEPA filters and their efficacy. And the first question that may be appropriate for you to ask any one of you is, please explain the term true HEPA filtration. Is there a minimum true HEPA value recommended for non-treatment rooms and treatment rooms, which you may not know? So if you could just give us the definition of true HEPA filtration.
Okay. So anything other than HEPA is marketing. HEPA is a military standard, filters that are tested to the HEPA specification. It's a whole filter standard, and they have at least a 99.97% removal for 0.3 micron particles, and therefore they have a higher removal for either smaller or larger particles, because 0.3 is at the bottom of the U generally for HEPA filters. So it is a very efficient filter. There is a lot of confusion in the space about how they're marketed, but that's the real definition of HEPA. Now, that efficiency number doesn't provide you with everything you need to know. The important number for any type of portable air cleaner is the clean air delivery rate, or CADR. That is the product of the flow rate and the efficiency through the air cleaner. If you know the clean air delivery rate, and it's on most filter specifications and product literature, if you know the clean air delivery rate and you know your room volume, you can calculate the air change rate through the device. But the important thing is not the efficiency or the flow rate by themselves. It's those things multiplied together.
And are those things easy to find, Jeff? Where am I?
If it's a legitimate filter manufacturer, they will publish the CADR.
Okay.
That's
okay.
The best I can do that.
So you just said that there is nothing other than a HEPA filter in terms of what you would consider to be legitimate?
No, I didn't say that at all. I'm just saying that a HEPA filter is very efficient, but there are many filters that, for example, have a lower efficiency but a higher flow rate that might provide a very similar or higher CADR. And so that's why the important thing is not to focus too much on any number other than the clean air delivery rate, in my opinion.
And the clean air delivery rate then, if the clean air delivery rate is higher, is that the units that cost $2,000 to $3,000 that are medically specific filtration units, or can dentists get HEPA filtration units that are not at that grade?
So the short answer is the parameter you want to pay attention to is the CADR. And that does scale a little bit with price, but there's a lot of other factors. But that's not the only thing that any dentist should consider when purchasing a portable air cleaner. There's obvious things like price, but a very important aspect of a portable air cleaner is what does it cost to replace the consumables, mainly the filters in the unit. And so the costs, as I see them talking to people who actually use them, the costs of any portable air cleaner are, the first cost is less important than the consumable cost. And so if you get a really expensive portable air cleaner and never change the filter, you're not doing any good beyond the first little while use of that device. And so the maintenance costs, and then there's a whole bunch of secondary issues. Graham talked about airflow rates, and there's been a couple of questions about, does a HEPA filter create airflows that might be a problem in an operatory? And the answer is, yeah, they can. And there's not a lot of standardization in the industry, but you do want to pay attention to airflow rates and whether you might be, for example, kicking up particles or droplets on the floor by the operation of your air cleaner. And then there's a lot of considerations, things like noise, aesthetics, other things, which are also important. But from a perspective of performance, CADR is the main parameter.
Okay.
And to mention is air cleaners are generally noted to operate when in the fallow time between your cases. So you stick them on at full volume at that time to speed the air through as quickly as possible, and therefore noise doesn't become so much of a problem then because you've got no one in the space,
Okay. A tangential question to that then is, do we need both HEPA filters as well as the extraoral aerosol suction, such as the portable dental unit with the arm that allows you to position the collection end above the patient's mouth at the same time?
I don't know if anyone else wants to take it. I'll say flat out yes. So the answer is, in indoor air quality, there's a hierarchy. The first thing you do is source control. That's your oral suction device. And then after you do that, you go to ventilation if possible. It's not always possible. It's complicated. And after that, you go to filtration. And I would see nothing different in a dental operatory than following that hierarchy.
Okay.
And just having said that, I mean, that's where I came from with the risk assessment part, because the guidelines that are out there are black and white. You have to do this, regardless of the procedure you're following. And that's where the risk doesn't fall together. Because if you have that technology where you're, again, removing the contaminant at source, that is the solution you want. You don't want it to get into the air and have to filter. You want to capture it at the source. And I believe there's a lot of things that dentists can do to reduce the amount of aerosols in the air instead of waiting for them to get there and then try and filter them out. And these are the solutions that should be looked for. So that local exhaust ventilation, to me, is, as an occupational hygienist, that is always going to be our first line. Remove the source.
Makes perfect sense. I think it goes back to Jeff's pile of manure slide.
Not to say that patients are piles of manure, just to be clear here.
Okay, there's a question I have regarding high flow extractors. I have seen high flow extractors. Should I use one, and how do they work?
Okay, I'm going to answer this only because we just did some testing in my lab on a high flow extractor. This was for some anesthesiologists at
Yeah,
Sick
so
Kids.
what's a high flow extractor?
Okay, so the best description I heard was it looks like R2D2, but it's essentially, put bluntly, a HEPA filter with some type of capture hood on an arm. So the idea is you can position the hood over or near the mouth of the patient, and it will capture the aerosol in that immediate area and deliver it to a HEPA filter. There's a variety of different commercial products on the market. Some are marketed specifically at dentists, some are marketed more for operating rooms or other purposes. Our preliminary tests of one device, so I'm not going to spend too much time on them, basically show that it was really quite effective. Depends on who you're trying to protect, but we were trying to protect anesthesiologists in an operating room, so a different scenario a little bit than a dentist, but it ranged from 50 to 80% effective in reducing the exposure during the procedure of the practitioner to a variety of kind of coughing and breathing scenarios. So I think they make a lot of sense. Again, there's real questions around costs. They have other downsides. They create a lot of velocity near the face. They might make some dental procedures more difficult because of access issues. So I'm not saying they're a silver bullet here or anything, but I do think they definitely have a role as kind of targeted filtration.
Do you have any idea what the price points are or what the range of prices?
No, because like everything else, there are so many different options and other things and qualities of devices and so on. They're certainly more expensive than a HEPA filter, than a portable HEPA filter. And I looked at a few in the dental marketplace, and I think that there's like a multiplier of, you know, you take a device and then you market it to dentists and you mark it up by a certain amount. And so that appears to be at play too. So I don't want to comment on price other than they're kind of pricey, I think, compared to maybe some other options, but they're completely independent of your HVAC system and other things. So I think that they're, for some practices, they're probably a pretty reasonable route for investment.
Okay. Here's an interesting question. It's if we have installed mobile air purifiers in each closed operatory where AGP aerosolized procedures will be done, do we need to worry about the HVAC of the building? Which, yes.
It's back to the draft.
Back to the same.
Yeah,
Yes.
you've got to watch where you position them, that you're not creating more drafts and creating more problems than you have in the first place. So just be careful about drafts. That's the big thing.
And I think one of the things you can look at there is if you ignore the HVAC of the system and just rely on the air changes of the air cleaner, that's assuming it's 2 or 0, probably doesn't make a whole lot of difference. So, but like Graham said, it needs to be effective where you put it and all the other factors that are going to make it a little bit of a burden for maintaining and stuff.
Yeah, I think it's back to the using the system, using the air cleaner when you've not got patients in the space at high speed. If you have it operating at low speed when you have a patient in the space, then you're minimizing the draft you're creating out of it and possibly not creating a problem. If you then take the patients out, close the room off and turn it on to high speed, then the drafts aren't quite as much of an issue because you're extracting everything in that fallow time, and in that time you've cleaned air in the space.
Okay.
And I don't know how the regulators are looking at it, but my advice would be when you're looking at your fallow time is it starts the second you stop the procedure that you're following. So, you know, in between, if you're trying to achieve a 6 or 8 minute turnaround time, I'm sure you'd recognize that after you stop the procedure, you know, the patient has to recover. There's some conversation. So, you know, those minutes should be tacked on to the fallow time that you're looking at, because the generation of the aerosols is essentially stopped. Now, I don't know if they're worried about people talking and laughing and that kind of stuff, but that's the advice I would give, to try and focus it on, keep your time in a reasonable amount.
I don't laugh much in the dentist.
Yeah, I was going to say the same thing. Yeah. but the other comment I would make is that I agree with that, with a little bit of concern around cleaning activities. Cleaning activities really can generate a lot of aerosol. And so in the operating room context, the clearance time is usually defined starting as when the cleanup process is finished. And so, you know, again, I'm not sure how much the risk is there, but that's just something to keep in mind, is that your activities can generate, after the procedure, can also generate aerosol.
Okay. There, as you mentioned, fallow time. So I'm going to ask the questions that came up regarding how to calculate fallow time. And one of the questions is, when calculating the ACH, is the final number the sum of the existing HVAC ACH and that of any air purifiers that we may install? How do we determine that when we currently have 0 ACH?
If you currently have 0 ACH, then
you can't, right?
Sure.
Okay.
Yes. Your fallow time is infinite if you have 0 ACH.
Yeah. But yeah, I mean, you can add the two together for sure.
Yeah.
If a floor-to-ceiling sealed operatory has access to a window that opens to the outside, is this considered a breach of infection control to open the window? How do we calculate fallow time with an open window?
Natural ventilation is very hard to model, but I would never discourage people from putting fresh air into the space. Fresh air dilutes the contaminants in the space. So the more fresh air you have coming into the room, the better, as far as I'm concerned.
To avoid some of these calculations, can I just use a HEPA filter in the HVAC system?
No, not in your conventional HVAC system. You won't have enough room in your air handling unit to fit on a HEPA filter. It's a very specialist type of filter, and the air handling unit needs to be designed to incorporate it. I'm sure Jeff will agree.
Yeah, absolutely. Yeah, it's a nice thought, but when you do see HEPA filters retrofitted into existing HVAC systems, they typically take a small bypass flow and put it through the HEPA filter. So most of the air is not, in fact, getting HEPA filtered.
There is another question here that I think is, I'm concerned I'll have to put an air exchanger to bring outside air in. These machines are very expensive when you have to retrofit. Do the standalone filter systems work to clean the air and remove viruses or droplets?
Yes.
Yeah, you certainly can. You know, if you pick a good one and use it well, absolutely.
However, I would add that everyone's got the same idea. So delivery and demand is a problem. You're gonna be on a waiting list to get one, probably. Going by what I've discussed with manufacturers at the moment.
Okay, there are some questions about ultraviolet lamps. Do they work? My portable filter has an ion or a UV setting. Should I use it?
So ultraviolet systems, just like everything else we've talked about today, span a huge range of different devices. What is mentioned specifically in the CDC document for dentists is upper room UV systems, and they can be very effective. We know for the coronavirus specifically, it's susceptible to UV light, but there are real questions of, you have to have the virus exposed to a big enough dosage of UV light, and you have to manage the airflow issue. How do you get airflow to the UV lights and back to the patient, back to the operatory area? And so there are a bunch of issues there. It is effective, but I don't think anyone should assume it's going to be cheap.
If you have UV in your portable air cleaner, then that's nice to have for sure, but it's just an additional thing that you're going to have to pay for, and look at changing the lamps as a maintenance item as well. So it's more cost again.
Are there other things that you would recommend that we have not asked yet, or that we have not discussed in terms of alternatives?
Alternatives to your ventilation system? Not really. I mean, you have the better your ventilation system, the more fresh air you have in your ventilation system, the less recirc you have in your ventilation system, given the climate conditions that we have. You don't want to have too much humidity in your space, but generally the more fresh air you can put into your system, the less drafts, the more air change rate, the better, really. And I think trying to alter your existing HVAC system to push more air through it is fraught with difficulty, shall we say. I think the best method is to possibly put in if you want to increase your air change rate, is to possibly put in a portable air cleaner, and just make sure your toilet extract system operates 24/7, getting outside your operatory again, so that any infection sources out with your operatory are controlled as well. Your ventilation system is working as much as possible with a high-grade filter, in addition to making sure that you're using as much fresh air as you can.
What about putting UV inside the HVAC? There's lots of questions about integration of systems within existing HVAC systems. And I am hearing all of you say that you do not believe that's the best approach, just because of how difficult it is. Not that it may not be maybe I should reframe, that it's a very difficult thing to do.
It's a difficult thing to do well. A lot of air handling units will have UV already to discourage organic growth on the cooling coil. That's not the same as taking disinfection out of it. To take disinfection, you need to put a duct-mounted high-level UV source, which has to have the air velocity across it at a particularly low rate to make sure it kills all the germs that you have. So it has to be well designed. And I think a cheap system that someone says, "Oh, I can install that in 10 minutes and you'll be okay," I don't think you really want to go down that route.
Okay.
And the only piece I would add to that is there is a downside to cheap ultraviolet lights. They use relatively cheap lamps, which have a wide distribution of light, including some very low wavelength UV light, which can lead to ozone generation. And so it's not a good thing to cheap out on. So that's part of the hesitation with UV. It's an effective approach, but it has to be done well, as Graham said.
Gentlemen, it's 2:30. I would like to ask a few more questions if you're able to stay on. We still do have a large number of attendees who might be interested in hearing the answers. So is that okay?
Yep.
Yep.
I do have one thing to add about the other question you had about is there any questions we haven't asked?
Yeah.
And I'm going to go back to risk assessment. And, so what is going to happen is when dentists start going back to work, the premiers of each province and Trudeau are going to be watching to see what the caseloads are that come out that may be associated with exposures in dentist offices. And if we control those things and there's no spike because that's associated with dentist office, then the regulars are going to start, I used to work for the Ministry of Labor, and they'll start leaving you alone because they won't think there's an issue there. So I just think, from my conversations with various dentists and Dr. Delansky and stuff, that there's a lot of things that dentists can do to reduce the amount of aerosols, and they already know them. They're using rubber dams. They're using different techniques that reduce aerosols, and the more you can incorporate those things in there and reduce the amount of contaminants coming off, overall, I think, dental, eventually they're going to just stop paying attention to what you're doing because you have things under control, and you need to be thinking about all the things you can do to reduce the concentration and time exposures.
How about negative pressure rooms?
Laura, if I could just add to what David just said. I've been following this for several weeks, literally trying to get my hands on every article and every publication that I can. And there are a number of Western European areas where dental offices never closed. Interestingly enough, the dental clinics in Wuhan never closed during the crisis. And to follow up on what David said, it's quite amazing that there have been no reports of clusters around dental offices. And personally, in an anecdotal, non-scientific way, I attribute it to what David just said. A lot of use of removing the pile of dung. In other words, we know from a couple of studies that high-speed evacuation done properly, you get rid of 90 to 95% of aerosols at the source. And the other aerosols that are escaping into the room and into the environment so far, and you could say, keep your fingers crossed, have not caused any reported outbreaks from December till now, when it was first reported in Wuhan.
Mm-hmm. I would agree with you, Bernie, and I know you've been keeping us updated on that, but I think the approach we're taking here is just extremely precautionary and trying to make sure that every single T is crossed and I is dotted. And the questions that are coming in are really indicating that people are going to be implementing these solutions, whether they need to or not, just so that they can have confidence that they can keep their patients, staff, and themselves safe. So one of the questions that has come in is about if we want to make sure we maximize the removal of droplets or particles, does it mean that we need to have two sets of measurements when we use our filters? Is a pre-fallow time measurement, a post-fallow time measurement, and shouldn't we be using the filters, the filtration units, while we're in the operatory performing the procedure as well? So it's a two-part question.
Okay, well, I think I said if you operate your portable air cleaner at low speed while you have a patient in there, and in high speed when you turn up, when you are in fallow time, if you like. That was my answer to that one.
Yeah, I think that's exactly right. Of course, you'll reduce your fallow time. I mean, I could put a jet engine with a HEPA filter on it in your operatory, and you would have a very short fallow time, but you would also not have any patients. So there's a balance here between noise and airflow and all the other concerns, and having a cleaning procedure. And I think Graham hit on exactly a good approach to that kind of thing. You know, a low period to help shorten the source, doing all the other things for source control, and then a high period when it's unoccupied.
And what about the question about measurement of the ACH, pre and post?
I guess I'm a little confused at the question, but I interpret that as there is one ACH calculation. It is the sum of the removal by any portable filters as well as any the HVAC system.
Okay. I'm going to change tack and ask you about masks. So the first question is, can N95 masks cause hypoxia over long-term usage or wearing?
Well, one of the things, so we have these things where I can't think of the term I'm looking for, but there's factors of when you want to change the filter out. And I can tell you, I've been, recently doing work in my attic, and I have I wear my respirator, and I actually have new cartridges on this one. They were getting quite blocked up, and we know when these things need to get changed when they start to get hard to breathe through. So what you need to do is put a new respirator on and find out what it feels like. And when it gets to the point where it's starting to be uncomfortable, then you should be removing it. So will it create hypoxia? Well, if you got dirty enough, I guess it might. I mean, fundamentally what's going to happen is you're going to start breathing harder because you're drawing air through a filter that's getting more and more plugged up with contaminants. But typically, they're unless they get plugged up with a bunch of stuff, they're not going to create a position where I would be worried about somebody having an oxygen deficiency. But it's certainly a factor if they're hard to breathe through. Like that's why they don't last forever. They get plugged up with stuff. Like they're very efficient at removing dirt and stuff in the air, not just the little particles, the big ones as well. And they will be hard to breathe through. And particularly if you're doing any work that requires you to increase your ventilation rate, you're going to start finding them uncomfortable.
You did say that N95 respirators are considered to be single use, but there are a lot of questions about reuse and disinfection and the possibility of that. Can you comment on that?
Health Canada have come up with guidelines on how to do all those things. They have guidelines for cleaning them, guidelines, like I said, the expiry dates and the reuse. Again, they were traditionally designed as, I mean, as a hygienist, we always call them disposable respirators. They're not reuse ones like this that obviously have a plastic, silicone, or other form of plastic base that, you know, you can get repeated things. But even I can't really show you the inside of it, but there's little valves and stuff in there that get distorted, and they don't last forever either. But they were really designed to be disposable. But we have to use them for as long as we can in these conditions. And like I say, when things change, we can go back to considering to be single use or disposable. But in the meantime, we need to find ways of taking care of them, putting them on properly, taking them off properly, so that we can get the most use out of them, and understanding when they fit and don't fit. So, you know, I'll just give you an example. People will complain, why aren't you wearing your respirator? Because it makes my glasses fog up. That's because you're not wearing it properly. If your N95 is causing your glasses to fog up, then you don't have a good seal around your nose and it is not fitting properly. So there is ways of doing what we call field checks, of checking to make sure the respirator actually is sealing properly. And these are all the things you should be doing to make sure you get the longest life out of them, is inspecting it before you put it on and looking and doing a field fit check that we would call it, and making sure you're actually getting a seal. And once you stop getting a seal, it's time to get a new respirator. Again, the issue is going to be is it get contaminated potentially with the COVID causing virus, and what you need to do with that. Again, Health Canada have guidelines for all of it, or for all those things.
Thank you. I think we're going to wrap up now, but I have a zinger of a question, which is one that just came in just a few minutes ago. And the question is, essentially, none of you is a dentist, but you know, Bernie accepted, but you've been sensitized to what dentists are going on over the past few months. So the question that came in is, if you were a dentist, what would you recommend to others to do to protect themselves, given the two sides of the knowledge that you have?
You mean protect themselves as a dentist?
To protect yourself. If you knew what you knew now and you were a dentist, so it would be your personal safety, you're not just advising others on what they should and shouldn't be doing as they return to practice, what would you do yourself personally?
I would put a higher grade filter in the ventilation system. I would make sure that it was operating 2 hours before and 2 hours after occupation. I would speak to David about mask fitting, and I would have the best aerosol source removal stuff I can possibly get my hands on, I think.
Okay, David?
Yeah, I can only echo that. I mean, so let's start with protecting the dentist himself, wearing a properly fitted N95 respirator to protect themselves, wearing an N95 respirator to protect their staff and their patients, controlling the people that are coming in and out of their office. And again, what we already talked about, trying to reduce the amount of aerosols as much as we can. And if we can't control them, then we need to go to ventilation. But, you know, all the hand washing and stuff, I just want to reemphasize again, it is not each one of those individual things that's going to save us. It's everything we do together that's going to reduce the risks as low as we can. So if people come into your office and they wash their hands, I've heard different things about mouthwashes and things that can be used to reduce the viral load. We don't have enough data on all this stuff, but it just makes kind of sense to me that why wouldn't you start trying to explore these different things? The more you can reduce the amount of viruses you're exposed to, because again, the data is showing that there's definitely a dose response relationship here. The lower your exposure, the lower your risk of contracting the disease. So,
and I won't repeat anything other than to say two things I didn't hear is don't forget your practice is more than an operatory. So the other spaces like bathrooms, waiting rooms, thinking about how things are moving in and out of the operatory, including people, are all important aspects that, you know, all of them are relatively low cost to deal with, but so just deal with them and do all the other stuff that that was already said.
Thank you. Are there any closing comments by any of you?
Thank you for having us. Okay.
Yeah, thanks.
Yeah,
Many
it's been
thanks
a
to all of
pleasure.
you for giving us the time to share your expertise and your experience. You wouldn't believe it, but we didn't get to all of the questions. There are a lot more. There are some central themes. The themes that we tried to address today were masks and mask fitting, air filtration systems, the difference between the portable as well as integrating into existing HVAC, the infection control and how to reduce the spread of virus outside of air filtration systems, and understanding more about whatever we know about how the virus is spread. We didn't get to all of it. We did make a commitment that we're going to try to answer all of your questions, or as many as possible. We think we answered most of them. We will, over the next few days, get back to you with questions that we were not able to address. We hope that collectively we were able to give you some information so that you can have more confidence in going back to practice. And we thank you for your time this afternoon. Any other comments, Bernie?
No, other than what I started with. The idea of this series is to try to get your practices back as quickly as possible. And we just hope that this helped you do that.
Yes, and remember that David recommends having a risk assessment done. And that's one of the key ways that you've got all these questions. That's one of the ways you can figure out where you are and what you need to do. So it's establish a clear and concrete plan to do so. If you haven't already done so, please reach out to one of our experts. I'm going to share here contact information. Give me a moment.
And just as you're finding that a little bit on the lighter side, just think about all the things that your mother told you as you're growing up that you're learning now. Wash your hands, what nurse has been telling you, wash your hands, you know, keep your fingers out of your nose, you know, make sure your utensils go back on your plate when you're eating, and not all these little things that I find when you really look at it, all these polite things that we're supposed to do, manners, following good manners, very many of them are trying to reduce the amount of exposure we get to biological agents. And I think it's something that's funny when I look back at some of these stuff. Well, why is that important? Well, we all know now how important it is to wash your hands and how long the nurse has been telling us that. So, and this isn't going away. I think we need to take everything we learned from this and go back and see how we can control exposures to the flu, because this is not new. I've tried to convince employers for quite a while that what would you do if 20-30% of your population got the flu? And now people are finally starting to see that, yes, okay, I can see what can happen, because this is obviously the worst case scenario. But we need to live and learn and move forward, and we'll be a lot safer and healthier moving forward once we implement some of these procedures and stuff and thought patterns. So.
And my mother always taught me to maintain my HVAC system. So.
Yeah, mine told
Your
me.
mother is
Filters.
unique.
And
But he's doing what he's doing.
She was ahead of her time.
I've always believed that dental offices have amongst the highest standards for infection prevention and control, especially for the last several years. And this just takes us to a new level, but we're starting from a really solid foundation.
Okay. Thank you, everyone, for your attendance today. Thanks to our speakers. I think I've put up a slide now on the screen that shows contact information. So if you want to grab a screenshot of that, feel free to contact any one of our speakers today, and we'll be getting back in touch with you. Stay tuned to the Tier 3 website, www.tier3.ca, for notice of upcoming events. We do plan to have more webinars in our series. And Bill, do you have any further comments? Bill's okay to go.
Sorry, I was muted and I had stopped my video, but no, I think it was great, guys. Thank you all very much for the help and the participation. We're going to keep working on this to help both our clients, our customers, and frankly, dentists who may never deal with us get their businesses back up and operating in a safe and effective manner. So thank you all, and it was nice to be hiding in the background for a change.
Thanks, everyone. This ends today's webinar.
Thank you.
Bye.
Have a great weekend.